Hey guys, today I want to be talking about a concept that I've been struggling to understand in math, but I think I finally mastered it enough to teach you guys, and I know a lot of my friends have also been struggling with this. So I'm going to put out this video to help you guys and help other people because in reality, there's not a lot of videos on this. Like I haven't seen any videos. So I decided to make one for you guys and anyone else that needs this video because it can be challenging to understand because it kind of defies it can trick your brain because it defies how functions work, and I'll explain why in a minute. All right, so whenever we have a composite function, we are always referring to a function within another function. So we could have, let me redo that, let me do an f like that, f of g of x. This is what we mean when we talk about a composite function. So when we talk about decomposite or decomposition, we're going to kind of take this whole function here apart and we're going to put it into two parts. So we would have f of g, f of x, and then g of x. So we kind of separate this into two parts. All right, up here we have a composite function with two parts. We have an outside part and we have an inside part, and I've labeled them different colors so you guys can tell the difference here. So first things first, when we're graphing, this video is specifically about graphing. So we're going to be decomposing the function and then graphing them, and that's what I can't find online. It's the actual graphing videos. So first things first, we always have to separate this into two parts. So we're going to have our h of x equals square root of 5 minus x, and then we're going to have two functions within this composite function here. So f of x, it's going to be in red. This is our outside function. It's going to be equal to the square root of x. And then g of x, which is our inside function in blue, is going to equal 5 minus x, which we can just rewrite as negative x plus 5 plus 5. So we can put the variable there for convenience. So now we take our graph. I'm going to try to draw a good graph here. All right, so the first thing that we're going to do is we're going to look at this inside function here, and we're going to graph this. So the inside function is the first thing we're going to graph. So I'm going to make this blue so it's easy for you guys to see and to keep track. So in the formula, y equals mx plus b, b is going to represent our y-intercept. So our y-intercept here is 5, and that means there's going to be a point at 0, 5. So I'm going to draw a point right there. So now our slope is negative 1. So every time we go down 1, we move over 1 to the right. So I'm just going to put some points here to guide me. It's going to go to like right there. That's going to be our x-intercept. So I'm going to try to do a line here. That's not very accurate. It's going to look something like that, and it's going to continue like that because it's a straight line, just with a slope. So it's a linear equation. So now what happens is we're going to take, and this is why I said it kind of defies the functions, because when you're talking about functions, you usually plug in an x value, but this time we're going to be plugging in a y value, which is super strange. This is why I couldn't really understand this concept very well, but this is how you're supposed to do it. So what do I mean? Okay, so first of all, the first thing we want to do is we want to look for limits. And what I mean by limits is what y values do we know that we can't plug into this equation. So, and when I mean plug into f of x. So here's what I mean. We see here that the y value is negative 1. But we know that we can't have a negative number inside of a square root. Otherwise, it's going to be imaginary and we're not going to be able to graph it. So instead, what we have to do is we just have to cross out these values. They won't work. and then start at 0. Let me draw a point here. All right. So now we can start at y equals 0. So we're going to check right here, and look at that. There's a y value right here in our g of x function. So we're going to plug in 0, because that's our y value, into this function. So we have square root of 0, because that's our y value. I know it's our y value, guys, not our x value. I know I got to keep repeating it because people can get lost there, and that's how I got lost. But we're plugging in the y value of our line here, of our g of x in the inside function. So square root of 0 is just going to be 0. So then we're going to have a point right here, a red point, which is the f of x. Then we move up a value. So we look at y equals 1. So y equals 1 intercepts right here. So that means we should have a point here depending on what our output is when we plug in y. So y, we're going to do square root of 1 equals 1. So we're also going to have a point here. So right there, we're going to have a point. So because y equals to 1, and then we just put in the y value there. So here's where it changes. When if I wanted to plug in y equals 2, then I'd have to do the square root of 2, and that's irrational. So that's going to be kind of tricky to do. So we're going to move up to a perfect square. So we can move up to y equals 4, because 4 is a perfect square. And then we know that if we do the square root of 4, our output y value is going to be 2. So right here, where there's a blue point, where y equals 4, so we're looking where on the function y equals 4. So right here, we're going to plug in 4, and then along here, we're going to plug in 4, and then we get 2. So now we've got to move down to 2. Oh, that's not a very good point. There we go. So now our function is going to look something like that, like a square root function. Hold on, let me just make it a little bit more curved. There we go, something like that. So that's how we do this example. So I'm going to show you guys another one, and then let's see if we can go through it together. For the next example we're going to be working on, it's a little bit more challenging, but let's see if you guys can figure it out. I understand if you guys don't, because it is significantly harder than the other one, but I'm still going to post it here, and I will explain it, so don't worry. So h of x equals 1 over x squared. So I'm going to give you guys a moment to pause this video and then try to solve this for yourself. All right, so now we're going to just go through it together, and you guys can compare your answers. So first of all, I'm just going to put my graph here so we have something to reference. All right, so what I'm going to do real quick is I'm just going to rewrite this, but I'm going to color code it. So we're going to have 1 over x squared. All right, so first thing we're going to do is we're going to separate this into two functions. F of x, which is going to be our outside function. Let me do it red. Is going to equal 1 over x, so that's our outside function. Let me redo that x, it's kind of sloppy. There we go. And then our inside function is going to be x squared. So g of x equals x squared. So first thing we do is we're going to graph our inside function. So we're going to graph g of x. We're going to graph g of x here. G of x. That's the only thing we're worried about right now. So g of x is equal to x squared. And when we are talking about x squared, we're talking about a parabola. So we see that there's no transformations done to this parabola, so it's just going to be like the parent function. So we're going to have a point here at 0, 0, then negative 1, 1, 1, 1, and then 2, 4, and then so on and so on, negative 2, 4. And I'm going to attempt to draw this to the best of my abilities, but it might not look super neat, but I'm going to try to draw a parabola here. It's just going to keep going on to infinity. And there we go. All right, so now, again, we're going to take our y values, but you guys may be wondering, how are we going to take a y value if we have a spot here and a spot here? Well, I'm going to explain right now. So first, how I like to think about it is what y value, or like where do we hit, or where do we touch the function at y equals 1? So actually, we can start with y equals 0, but as you guys know, when we have a rational function, there's just going to be an asymptote there, so we don't have to worry about that. So that's why I just pointed here. So where on the function do we touch when it's y equals 1? So when y equals 1, we're going to touch the function here, and we're also going to touch it here. So we're going to know we know our function is going to be even, and it's going to be symmetrical. So I'm going to show you guys how this works out. So when y is 1, and we plug this into our function, so over here we do 1 over 1. There's just going to be a point, because 1 over 1 is equal to 1. There's just going to be a point here for f of x. So now what we have to do is, by the way, we're graphing our composite function, or like our decomposed function, I should say. So now what happens is we can pick another value here. So obviously here I'm just going to draw an asymptote. So we know that we're not going to have any values here. So now what we can do, we can pick another value. So let's say we pick, I don't know, 2. So where y equals 2, so y equals 2 is going to be like, actually, I'm going to pick a better value. I'm going to pick 4, because 4 is just going to work out easier, because 2 is, as you guys know, it's going to be kind of messy. So we're just going to pick a point that we already graphed, because it'll just be much more convenient. So let's take this point here. So on this side, by the way, we can also put a red point here because it's symmetrical, we said. So back to what I was saying, y equals 4. So we can plug this into our equation, or our function, f of x equals 1 over x. So we can do 1 over 4. So guys, where y equals 4, where it touches the function, the g of x function, is where we're going to put our point. So we're going to put it down here. That's not an asymptote, but I'm trying to help you guys visualize this. So y equals 4, we're going to plug that in, and we're going to get 1 over 4. So now it's going to be like 1 over 4 is like right around here. And then we can do the same thing here, because if we look at y equals 4 right here, it's going to be equal to y equals 4. We plug that in, and it's just going to be the same. You guys can test that out if you guys don't believe me, but that's essentially what it's going to be. So let me just get rid of the arrow first. Okay, so now we can take a value that's closer to 0 here, but not exactly 0. So we can take a fraction. We can take 1 over 2. So let's take 1 over 2. So right here, where the function is equal to y equals 1 over 2, so it's going to be right around here. We're going to plug in, so this is going to be like where we're going to place our point. It's going to be along this x value here. So y equals 1 over 2, we're going to plug that in. 1 divided by 1 over 2. We just, whenever we're dividing number by a fraction, we just do the reciprocal, and then we can do 1 times 2 equals 2. So we can, right here we said this is where y is equal to 1/2. We're going to move up to 2, and then put our point right there, and then we're going to put 1 here as well. So if we continued this with 1/3, 1/4, and we just kept getting closer to 0, the closer we got to 0, the closer we'd get to infinity. So our function would look like this, and it would never touch the asymptote, obviously. But then you guys may notice that if you tried doing other perfect, if you guys tried doing other squares, you guys, like if you guys were to plug in 9, you'd probably get 1/3. Or wait, actually, let me test that out. Let me do 1. Let's say y equals 9. Actually, on 3, it would be, pardon me, on 3. So if you guys were, if the x value is 3, you guys would have y equals 9. And then on 3, you'd get 1/9. And you'd get another point here. But essentially, you guys are going to have 2 asymptotes. So wait, that's not accurate at all. This goes on y equals 0. And then you'd have another line going here. Oh, that touched. It's not supposed to touch the asymptote. It's not supposed to touch, but it's kind of hard to be precise. So I really want to be as accurate as possible with this, because I don't want to confuse anyone, because some of you guys are already confused enough. So I just want to make this easier for you guys. All right, that's as close as it's going to get. But this is what our decomposition function would look like. All right, now finally, for our last example of today, which is also going to be pretty hard, actually harder than the last one, I think, is h of x equals e to the power of the square root of x. So go ahead and try to solve this, try to graph it out, and then we'll review. All right, so first thing, again, I'm just going to color code this. So our outside function is going to be e to the power of x. Wait, actually, I'm getting too far ahead of myself. I'm just going to rewrite this color coded. So e is going to be red because that's our outside function, and then our inside function is going to be square root of x. So again, we got to decompose this. So now we're going to get f of x is equal to e, because that's our outside function, and then g of x is going to equal the square root of x. So again, here's our two functions, and then I'm just going to get my graph over here, and we're going to start graphing. So first thing, again, graph g of x, because it is our inside function, so we just got to graph that out. So square root of x function, there's no translations or transformations, anything like that. So we're just going to graph our parent function. So 1, 2, 3, 4, 1, 2. It's going to look something like that. And then I'm going to try to draw this. Oh God, that was pretty bad. It's so hard to draw with a mouse. Okay, wait, no, it does not come flat there. Give me a sec, guys. There we go. It's going to look something like that, our square root function. All right, now, what we have to do is, again, look at the y values of this function. So, first things first we can do is we can check y equals 0, and right here it's going to equal 0. So when we plug in 0, it's going to be along the x equals 0 line. So around here, we're going to have a point somewhere. So when we plug in, sorry, it should be like that. F of x, or sorry, e to the power of 0, because that's what we said our y value is going to be. It's just going to equal 1, because anything to the power of 0 is just 1. So we're going to have a point right here. It's a little messy. Let me try that again. All right, so we're going to have a point right there. Now, we're going to look at y equals 1. So y equals 1 right here, because this is our y equals 1. And we're going to know that we're going to have a point along x equals 1. So somewhere here I'm going to have another point. So y equals 1, we're going to plug that into our function. E to the power of 1 is going to equal, I believe, 2.71. So 2.71, roughly. So now, along here, x is equal to 1. We're going to move this up to 2.71. So it's going to be like somewhere here. And now we could just keep doing this with other points. Just like for if we wanted to be more accurate or precise. So again, we could just take another value. So if we wanted to do, let's do 2 here. So here would be 2 because y equals 2. It's like around this point. It's supposed to be there. I know it's a little bit off, but we would have another point here because y is equal to 2 right there at that point. So here is where we would have another point. So if we were to do e, just using my calculator here, e squared is going to equal 7.389. So we'll call it 7.39, and it would be around 5, 6, 7, 8, 9. I'm just adding some more lines. So it'd be 1, 2, 3, 4, 5, 6, 7.39. So it'd be around here. And remember, it's going to be right on top of this point because that's where our y equals 2 on our inside function. And then our final function is going to look like that, something like that. So those are decomposition functions. I really hope this helped. This was a really tricky concept for me to understand because I just didn't get the gist of plugging in y values. So, but this, I'm pretty sure this is how you, not pretty sure, I should be giving you full confident answers, and that's what it is. I'm fully confident that this is how you do it. And if you have any questions, just let me know. I'm still getting familiar with this, like doing harder concepts, like harder than this, but this is the basics of how you do decomposition, how you graph decomposition functions, and I really hope this helped. Thank you for watching.